If you went through that black hole, you would reach another universe. There is now a connection between quantum computing and black holes. In this eye-opening video, we explore a groundbreaking and terrifying discovery made by the James Webb Space Telescope inside a black hole, explained by none other than Bill Nye, the science guy. A black hole is a star so massive that even light cannot escape it because of its immense gravity. The mysteries of black holes have puzzled scientists for decades, but now, thanks to unprecedented capabilities, we've glimpsed something truly astonishing. The supermassive black hole consumes the equivalent of one Earth every second. It's stunning and compelling, the first-ever image of a black hole in space. Prepare yourself as we delve into the incredible details of this cosmic revelation and what it could mean for our understanding of the universe. Stars, at the end of their life, much bigger and more massive than the Sun, run out of fuel and start to collapse as gravity squashes them. Black holes are tricky to detect. It was quite a challenge to search for the first one, even though Einstein's theory of relativity predicted they were common. Unlike stars, black holes do not emit any light of their own, making their size and spin the only measurable properties we have. Photographic evidence of black holes confirming their existence has only recently become available. However, conclusive proof of black holes was lacking for quite some time. The first black hole, Cygnus X1, was discovered in 1964, but it took over 30 years for authorities like Stephen Hawking and Kip Thorne to reach a consensus on whether Cygnus X1 was indeed a black hole. Hawking, a prominent figure in black hole research, was confident in their existence but cautious about the lack of definitive findings. Hawking and Thorne were almost certain that Cygnus X1 was a black hole in 1975 when the wager was initially cast, and by 1988 they were 95% sure. Still, Hawking waited until 1990 to concede defeat when more observations provided sufficient proof. The initial discovery of Cygnus X1 was made using 2 Geiger counters launched into space on a suborbital rocket, detecting a signal pinpointed to a system 7,200 light-years away. The system featured a blue supergiant star orbiting another large object radiating strong X-rays, which would make sense if it were a black hole. Much research has focused on Cygnus X1 since its discovery, revealing that it is 21 times the mass of the Sun, making it the largest stellar mass black hole found without gravitational waves. This discovery challenges long-held assumptions about black hole formation and the mass loss experienced by stars over their lifetimes. Cygnus X1 breaks records in more ways than one. Its extraordinary bulk and the fastest rotational velocity of any black hole discovered so far, approaching the speed of light, defy the accepted pattern of black hole evolution. Although definitive evidence of black holes has only recently been discovered, it is increasingly apparent that they are scattered throughout the universe. Even if scientists eventually untangle all the mysteries of Cygnus X1, the first of its kind, countless others still hold many surprises. Less than 2,000 light-years away from Earth, scientists have discovered a sleeping giant, the Milky Way's largest stellar black hole, Gaia BH3, with a mass 33 times greater than that of our Sun. Despite being the second closest known black hole to Earth, Gaia BH3 remained undiscovered until recently. Gaia BH3 was discovered by accident while scientists from the European Space Agency analyzed data from the Gaia mission, which maps our galaxy in 3D. The discovery of this dormant black hole, which isn't actively siphoning energy and materials from a companion star, was a complete surprise. Typically, stellar black holes in our Milky Way have a mass around 10 times that of the Sun, with Cygnus X1 holding the record at 21 times the Sun's mass. However, Gaia BH3, with a mass of 33 solar masses, is still tiny compared to all black holes. For instance, the central supermassive black hole in our galaxy, Sagittarius A*, is 4 million times larger than the Sun. Gaia BH3 is the second closest black hole to Earth, behind only Gaia BH1, which is 1,500 light-years away and 10 times the mass of the Sun. Astronomers now have more evidence to piece together how stellar black holes form from the demise of long-lived stars. Stars with lower concentrations of heavy metals are thought to be the source of more massive stellar black holes. These metal-poor stars, mainly composed of hydrogen and helium, are believed to experience slower mass loss, leaving more material available to create massive black holes when they die. Using the James Webb Space Telescope, JWST, Astronomers have discovered an extremely red supermassive black hole growing in the early universe's shadow. As the universe expanded, the supermassive black hole took on a reddish color. 700 million years after the Big Bang, the light heading our way is redshifted, suggesting a thick veil of gas and dust surrounding the black hole. Lucas Finkelstein and Eyal Zitrin of the Ben-Gurion University of the Nejev's astronomy team established the supermassive black hole's mass using JWST data, finding it to be about 40 million times the Sun's mass. This discovery starkly contrasts with the galaxy it inhabits, showing that the supermassive black hole is quickly devouring the surrounding dust and gas. Located about 12.9 billion light-years from Earth, this quasar-like object was initially identified by its red appearance. Quasars are created when large amounts of matter surround supermassive black holes, forming a disk of gas and dust that feeds the black hole. The immense gravitational influence of the black hole churns this matter, generating intense temperatures and causing it to glow. The light emitted by quasars can be so bright that it surpasses the brightness of all the stars in their surrounding galaxy. The JWST detected this supermassive black hole as a tiny point due to the massive amount of radiation it was emitting. The object was identified as an unusual star-forming galaxy based on color analysis, supporting the theory of supermassive black holes. Its small size and apparent supermassive black hole nature stood out from other quasars discovered in the early universe. This discovery was made possible by gravitational lensing, an effect predicted by Einstein in 1915. Einstein's theory of general relativity suggests that objects of mass warp the fabric of space and time, which are united as a single entity called spacetime. This curvature causes gravity to exist, and the more massive the object, the more extreme the curvature. The curvature of spacetime also affects the light emitted by stars, bending it as it passes near massive objects. This phenomenon, known as gravitational lensing, allows us to see distant objects that would otherwise be invisible. The JWST used this effect, aided by a galaxy cluster called Abell 2744, to magnify the light of distant galaxies and uncover the crimson quasar. This new information adds to the growing body of evidence that the early cosmos was populated with supermassive black holes, which can be millions or even billions of times heavier than the Sun. Now that this behavior has been observed in multiple additional early universe supermassive black holes, it sheds light on the growth of both the black hole and the host galaxy, as well as the interaction between the two. The classic chicken or egg dilemma, but on an astronomical scale, is still unresolved. Did the galaxy or the black hole come first? How massive were the first black holes and how did they grow? Researchers may have discovered proof that microquasars, which are vampire black holes that devour nearby stars, are cosmic particle accelerators, unleashing unexplained high-energy cosmic rays that hit Earth. These massive black holes consume material from nearby supergiant stars in binary systems, and some of the star matter is ejected as relativistic jets traveling at great speeds. Microquasars are smaller versions of quasars, both powered by supermassive black holes devouring nearby matter. Discovered in 1912, cosmic rays can hit Earth with energies reaching 10 to the power of 20 electron volts, far more energetic than particles accelerated at the Large Hadron Collider, the world's most powerful particle accelerator. The hypothesis suggests that supernovae and microquasars are the universe's most potent cosmic particle accelerators. However, evidence of microquasars accelerating particles to such high energies has been scarce until now. Using the High-Energy Stereoscopic System, HESS, scientists identified exceptionally high-energy gamma rays from the jets of the most powerful microquasar in the Milky Way, establishing the link between cosmic rays and microquasars. This microquasar, SS433, generates high-energy cosmic rays through its jets, which collide with surrounding matter, producing a shock front that accelerates electrons to extreme speeds. These gamma rays are a byproduct of this process. SS433 was the first microquasar ever discovered, located at the center of the W50 supernova remnants, affectionately called the Manatee Nebula. SS433 has been the subject of extensive research for decades. The system consists of a white supergiant star and a black hole about 10 to 15 times the Sun's mass. They orbit each other every 13 Earth days, with the star's outer layers being stripped by the black hole's gravity. Some of this material forms an accretion disk around the black hole, while other parts are ejected as jets traveling at 26% of the speed of light. These jets, spiraling in a corkscrew pattern, shape the W50 supernova remnants, giving it the appearance of a manatee. A section of the W50 remnants called Fermi bubbles features twin lobes of gamma rays extending for tens of thousands of light-years above and below the galaxy. The Hess Gamma Ray Observatory detected cosmic rays with energies up to 25 tera-electron-volts from the jets of SS-433, the first confirmed instance of microquasar particle acceleration. The European Space Agency's X-ray Multimirror Mission, XMM Newton, has discovered a microquasar in the Milky Way ejecting a mysterious ring of X-rays in a repeating cycle. The study of microquasars provides insights into how black holes evolve and their role in cosmic phenomena, contributing to our understanding of the universe's most enigmatic objects. What are your thoughts on this mysterious discovery? Let us know in the comments below. Don't forget to like and subscribe for more amazing content.